The ABmm is a vector spectrum analyzer in the millimeter regime or sub-terahertz regime. It has a setup for quasi-optical investigation of material in frequencies between 9 and 660 gigahertz. The electronic system is producing signals between 9 and 18 gigahertz. Then it is taken out by a coaxial cable to a transmitting antenna. After, it can be multiplied and transmitted through the quasi-optic system. It is received through an antenna connected with a coaxial cable to the electronic system. Then, through comparison to an internal signal, it can determine the magnitude and phase of the received signal. This way, the ABmm system analyzes both phase and amplitude of the radiation and both reflected and transmitted signals from a sample. As far as you go below the metal plasma frequency, metals behave like theoretical metals, which means no radiation can penetrate the metal and a striking beam. It is fully reflected. Therefore, in a millimetric wave system, the radiation principles taught in electricity and magnetism courses appear in absorbable means. For focusing purposes, we use mirror optics rather than lenses because the wavelength is long enough and an aluminum plate is easily processed into a concentrated parabolic mirror with roughness, much smaller than the wavelength. We use a tungsten mesh as a polarizing beam splitter because the electric component of the radiation, which is parallel to the mesh, is fully reflected, and the electric component of the radiation, which is perpendicular to the mesh, is transmitted through the beam splitter. When we need to absorb radiation, which we don't want to reflect back into the system, we use an absorbing material formed in a moth-eye shape, which, in this wavelength, looks more like a porcupine back. This shape is used as an anti-reflective metastructure. The system radiates Gaussian beams. In focal points, the wave front can be considered a planar wave front for the purpose of analyzing the optical interference through the sample. For more information, please contact us.